Right guys, this little video is to explain question 6 on page 144. There's been quite a few questions about this one and how to do it, so I'm going to quickly run through it with you guys. So the question states, for the combustion of propane gas, you will need a sufficient amount of oxygen. Air consists of approximately 22 mass percentage of oxygen, and the formula of propane is C3H8. Okay, right, so question A, so 6A, would be the following. Write a chemical equation for the complete combustion of propane gas. So for complete combustion, all right, you are going to take propane, so C3H8, plus, if it's a complete combustion, you're going to need to react it with oxygen, and that's going to give you two products. You've got carbon and oxygen, so that's going to give you carbon dioxide plus water, the hydrogen and the oxygen that's left over, H2O. All right, so now let's quickly balance this thing. There's 3 carbons there, so there needs to be 3 carbons there. There's 8 hydrogens there, so therefore 4 times by 2 gives you the 8 hydrogens. And now let's just see, we've got 8 oxygens there and 6 oxygens here. So that gives me a total of 10 oxygens. So this one has to be 5 oxygens. Okay, so now we have our balanced equation. So that's question A. Question B says the following. Calculate how many grams of oxygen are needed for the complete combustion of 125 grams of propane gas. So now this is just like the questions that we've been doing in the previous chapter, where we had to look at, we know how much propane gas, we want to know how much oxygen. So in order to see the mass ratio for these two, you have to then work them out. So 3 times 12 plus 8 gives me 44. And oxygen is 16. So 2 times 16 is 32. 32 times by 5 gives me 160. All right. So that is in units. We now know that we've given 125 grams of propane and we want to know how much oxygen is required. Okay, so just the same ratio. So if we look at this ratio, 44 to 146, 122, that one's got to be a lot bigger, 4 times bigger. So roughly, so we've got to then put the larger number over the smaller one, multiply by 125, and you end up with 454,5454, and you make it 55 grams. All right, so that would be grams of oxygen. Okay, so you need 154,55 grams of oxygen to react with propane, a complete reaction. Right, so that would be answer to B. Question C says the following. How many grams of air are needed for this combustion? So for air, you have to go back to the question where it talks about the fact that air is 22% of the mass of, 22% of the mass of air is oxygen. Okay, so that means that I want to take this amount, so 454, and keep the decimal places the way they, not the rounded off answer. Okay, keep it what you had, and then I'm now want to work, because that is now 22% of the total. So what is the total amount? You then got to multiply it by, instead of 22% would be 22 divided by 100. All right, this, we're going to flip it around and we're going to make it 100 divided by 22 to get the total amount. Okay, so when that multiplied together, divided by 22, we end up with 2,066,12 grams of air. Okay, now D. Question D says the following. The density of air is 1,29 kilograms per meters cubed. How many liters of air are needed at least to complete this combustion. Okay, so we know from our previous stuff that that density is equal to mass divided by volume. All right, and so this density is 1,29 kilograms per meters cubed. All right, so kilograms per meters cubed. So now we're going to say, okay, let's just have a look at what volume we've ended up with. So I'm in grams, so I'm going to make this into kilograms, so it's going to be 2,066 roughly, and that gives me my volume. Okay, so therefore we do a bit of maths. Volume is equal to 2,066 divided by 1,29, and we end up with 1,6 6 zeros, 1,6 is fine. 1,6 meters cubed. All right, meters cubed. All right, and then we've got to convert that to liters. Okay, so meter cubed is a kiloliter, so that's 1,6 kiloliters. All right, so that'll be 1,600 liters, and that's your final answer. All right.